iC-Haus Integrated Circuits.
Welcome. My name is Marcel Reuter, and today I'm going to present you bridge components for BiSS. I will start with an introduction to the BiSS Interface platform and then present you the BiSS Interface components iC-MB4, iC-MCB, iC-MCW and iC-BL. So let's start with an introduction to the BiSS Interface platform. So it all started with a BiSS Interface, which is nowadays the BiSS protocol, which is a continuous bidirectional serial synchronous interface for high-speed isochronous process data transmission. A couple of years ago, we have introduced the BiSS Safety profile definition, which is a simple profile definition for the BiSS protocol. It is suitable, or it enables you to use the BiSS interface in safety-critical applications up to SIL3. And recently, we have introduced the one-cable technology BiSS Line, which enables you to use the BiSS interface features for robust power and data transmission over just 2 wires. Since I'm not going too much into detail today regarding the BiSS interface platform, I recommend you to take a look at our webinar that we have recorded about a year ago, which introduces you to the BiSS interface platform. For now, it is sufficient to understand that the BiSS interface platform is fully compatible to each other. All right, now let's take a closer look on the bridge components for the BiSS interface platform. There are actually 2 groups. One is the BiSS group with our BiSS master iC-MB4, our BiSS slave iC-MCB, and our BiSS monitor iC-MCW. And on the other hand, we have a BiSS line component iC-BL, which can be used on both sides of the transmission line. BiSS has been developed especially to comply with requirements for the motor feedback applications or motion control applications, and therefore you find typical applications in drives, PLCs, encoders and robotics. Furthermore, with BiSS Line and iC-BL, we are also able to establish robust SPI links over just 2 wires. The required transceivers, RS422 for BiSS or RS485 for the BiSS Line communication, are already on chip. For implementing our components into arbitrary platforms, we have implemented several interfaces, for example SPI, and of course also for iC-BL, the BiSS protocol. All the components comply with the corresponding protocol, so with BiSS or BiSS Line, and iC-BL even provides further features such as a DC-DC converter, which is used to generate a sensor supply voltage, a one-time programmable memory that allows you to save the configuration of iC-BL without the need of an external EEPROM device. And of course, forward error correction is already performed on chip. So now let's take a closer look on BiSS interface. The BiSS interface protocol is already established and enables high-speed isochronous process data transmission. For today, we do not go too much into detail, but we focus on 2 aspects. One is that in point-to-point configuration, we need at least 6 wires, 2 differential pair of wires for the differential clock and data transmission, and 1 pair of wires for the power transmission. And on the bottom, you can find the BiSS frame. Here you can see in blue the data which is transmitted. That can be sensor data. And you will also see 2 yellow bits, 1 CDM bit in the clock signal and 1 CDS bit in the data signal. So there is another communication called control communication, which enables you to access registers of the BiS slave. So since there's only one bit in each direction per BiS frame, it requires several BiS frames to perform a complete control communication. Control communication can be used to configure a sensor, to calibrate a sensor, but also to read additional sensor data, which is accessible within the slave's memory. How that looks like, we will see later on my slides. All right. In the past years, I have gained the experience that ICMB4, our BiS master, and ICMCB, our BiS slave component, get confused at times. Therefore, on this slide, I just want to present you that ICMB4, our BiS master component, is typically implemented in drives or PLCs, so on the control side, and our BiS slave component, ICMCB, is typically implemented on the sensor side, so in encoders, torque sensors, or arbitrary sensor technologies. Since ICMB4 is also very established in the field, we just want to focus on two aspects. One is the typical configuration for a single BiS device connection. So what you can see here is a host microcontroller on the left side, which accesses ICMB4, configures ICMB4, and therefore controls the BiS communication. What you can also see is that ICMB4 has the RS422 transceivers already on chip, and therefore enables a direct connection to a BiS-C sensor, such as an encoder. In another configuration, we can also access two encoders in parallel. To this end, we use two physical BiS interfaces within ICMB4, but then we cannot use the internal RS422 transceivers. So in that case, we need additional RS422 transceivers to enable this parallel connection to the BiS encoders. This kind of application or configuration is quite typical if you have two BiS sensors which are not prepared for daisy chaining, so don't have an SLI input accessible. In that case, you cannot daisy chain the sensors, but need to access them in parallel. Okay, now let's take a closer look on ICMCB, which is our BiS slave component, also suitable to implement SSI slaves, and actually has two blocks that are of interest. One is the SPI slave block on the left side, which is used by a microcontroller to configure ICMCB on startup and provide sensor data. On the right side, you can see 6 I/O pins of a crossbar, where different functions and features can be assigned to. Typically, that can be one SPI master interface, which enables ICMCB to automatically read out SPI sensors. Furthermore, you can also assign BiS features to the 6 I/Os, which enable you which enables you to configure BiS daisy chaining or bus configurations using ICMCB. And last but not least, you have also access to an interrupt signal, which can then be used by the host microcontroller. Here you can see a typical application for ICMCB. It is an encoder for motor feedback. What you can see on the right side is, or in the center, is the host microcontroller, which configures ICMCB on startup and then provides data of a position sensor, and in this case also of the temperature sensor data. Since the position data is typically required in every BiS frame to perform motor feedbacks, the host will configure a data channel within ICMCB for this position sensor data, And for the temperature sensor data, we can do either the same, so establish another data channel. In that case, the complete data, position data, and temperature sensor data will be transmitted completely to the BiS master in every BiS frame. Or in the other case, we just store the temperature sensor data within the host microcontroller's registers and then can access the temperature sensor data through BiS control communication. In that case, we do not slow down the position data transmission. Okay, imagine you already have an encoder implementation and you want to add some smart features. So additional data for condition monitoring or predictive maintenance. In that case, once again, the host microcontroller configures iC-MCB on startup and then provides the additional sensor data. That can be, in this case, the acceleration sensor data and the torque sensor data. The encoder IC with the BiSS interface uses the RS422 transceivers of iC-MCB to transmit its data differentially. So in that case, you do not need an additional RS422 transceiver, and you can simply extend an existing BiSS implementation by additional sensor data. You could also think about additional operating modes that you can implement in the host microcontroller unit. So you can, for example, have one operating mode where only the acceleration sensor data is transmitted, one operating mode where only the torque sensor data or arbitrary other sensor data is transmitted. Or you can also have an operating mode where both sensor data are transmitted completely in every BiS frame. All right. There's another option to use iC-MCB. In that case, we use the SPI master interface of iC-MCB to access an acceleration sensor automatically. So in that case, the host microcontroller just needs to configure iC-MCB on startup and maybe perform register accesses if available. So in that case, you just need a low performance host microcontroller which can be available at low prices. All right, now let's take a closer look on BiS Safety, the profile definition for BiSS. So it is a simple profile definition and 100% compatible to the BiSS protocol. We just use BiS interface features such as daisy chaining of two sensors and different CRC polynomials to comply with safety integrity levels of up to SIL3, while still maintaining also fast safety cycle times of about 31 microseconds. What you can see below is a typical BiS safety frame. You see a control position word, which is used for the motor feedback. And you see the safety position word, which is used to ensure that the data transmission was successful. The control position word contains multi-turn and single-turn position information, one error bit, one warning bit, and the whole data content is protected by a 6-bit CRC. The safety position word contains also multi-turn and single-turn information, as well as the error and warning bit, and has an additional sign-of-life counter of 6-bit. The sign-of-life counter is just a counter value incremented with every new generated position word. And the whole data content of the safety position word is then protected by a 16-bit CRC. So here you can see a typical BiS safety setup. On the left side, the safety drive, and on the right side, the safety sensor. Within the safety sensor, the control position word is generated by one sensor, and actually all the iC-Haus BiSS slave components are suitable to generate the control position word. The BiS safety or the safety position word requires an additional 6-bit sign-of-life counter and the 16-bit CRC. And there are still a couple of components that iC-Haus provides for generating the safety position word. And then iC-Haus even provides products which are suitable to generate both position words within one package. So if you're interested in the safety implementations, I can highly recommend the iCRZ or iCRB. On the safety drive, we have our standard ICMB4 for controlling the BIS communication, and we have the BIS monitor, ICMCW, which simply observes the BIS communication between master and slave without affecting the communication and provides the data to microcontroller units, safe microcontroller units in that case, who then perform a frame data check. So it is possible to establish a system which complies with a BIS safety profile by simply using our bridge components ICMB4, ICMCB, and ICMCW. However, please always keep in mind that BIS safety is only the profile definition, so ensures that the data transmission has been successful without any errors, and it does not protect or makes the devices themselves and the systems already safe. So in that case, it might still be required to detect further failure modes. So for example, establish a voltage monitoring to detect errors regarding the power supply. Okay, now we go on to BiS Line, which is our one cable technology for the BiS interface, which enables a robust power and data transmission over just 2 wires over transmission lines of 100 up to 100 meters. On the right side, you can see 2 different topologies. One is the 2-wire topology, which requires additional coupling elements for modulation of the power and the data signals. And one is the 4-wire topology, where we do not have these coupling elements, but require additional wires. So in fact, you as a customer can decide on your own. If you have the space on the PCBs, then you can add the additional coupling elements and do not need additional wiring. Or if you do not have the space on the PCBs, so in very compact system designs, then you can still use BiS Line using 4 wires. I will not go further into detail of the BiS Line communication. So if you're interested in another introduction to BiS Line with more details, then please take a look at our webinar, which is also available on YouTube. For today, it is sufficient to understand that BiS Line is actually BiS-C, but requires fewer wires and enables and increases the data availability by simply using the forward error correction. All right, what are the characteristics of our ICBL bridge component? First of all, it can be used on both sides of the transmission line, so it's a BiS Line master or slave. It has the RS485 transceivers already on chip, which are required for the BiS Line communication, and has some DC-DC converter on chip, which enable you to generate a sensor supply voltage out of the up to 30 volts of supply, which are transmitted over the transmission line. Furthermore, we have 10 I/O pins within the crossbar, which enable different interfaces such as BiS, SSI, SPI, and I2C. And last but not least, there's a one-time programmable memory already on chip. That means that you, for basic system setups with up to 3 sensors, you do not require an external EEPROM device for storing the configuration of ICBL. This is already done on chip on ICBL. Okay, let's start with some applications with ICBL. What you can see here is a typical BiSS Line encoder application. On the left side, there's our BiSS Line drive, or PLC, which has a host microcontroller which accesses ICBL through SPI and then controls and configures it for the BiSS Line communication. And on the right side, you can see another ICBL component which has two sensors connected to its 10 I/O pins. So in this case, we have a BiSS sensor which provides position data and is required to be transmitted completely in every BiSS frame. And we have an I2C sensor whose data is stored within ICBL's registers. Since the temperature does not change very quickly, we can simply store it in the register and access it through BiSS control communication, so with 1 bit per BiSS frame in each direction. In another example, we have replaced the I2C sensor by an SPI sensor. In that case, we configure 2 data channels, so one for the BiSS sensor and one for the SPI sensor, and transmit the data of both sensors completely in every BiSS frame. So that can be used for condition monitoring, for instance, to implement further sensors such as an acceleration sensor. Now let's think a bit out of the box. So although BiSS Line has been designed according to the BiSS protocol and to comply with all of its features, you can actually use BiSS Line without using the BiSS protocol. And that's what we've done here. We have a host microcontroller in the master device and a host microcontroller in the slave device, and we can transmit data from both microcontrollers in each direction. So it is possible to transmit data from the BiSS Line master to the slave and backwards. This can be quite useful to implement robust SPI links over longer distances, so over several meters, and also to which might be required or which is required especially in disturbed environments such as in construction machinery. Last but not least, straight from the lab, I would like to show you a setup where standard BiSS components are simply extended by BiSS Line communication using our ICBL evaluation boards. So what you can see here is on the right side our BiSS master MB5U, it's a USB adapter, and on the left side our iC-MHM, which is a magnetic encoder IC. And then you can see a big board connected to our MB5U BiSS master, which is our BL1D, which acts as a BiSS slave and BiSS Line master at the same time. And the smaller board on the left side is our BL3M board, which acts as the BiSS Line slave and BiSS master at the same time. So by simply pre-programming our 2 ICBLs, we can add them in between of a BiSS communication and then have a robust and protected transmission over just 2 wires. So that's it for today. Thank you very much. I think I was able to show you that the BiSS Interface platform offers functions and features for all kinds of motor feedback applications and even beyond, thinking about the microcontroller links. iC-Haus provides the components for implementing BiSS into any device and platform. And we already have the evaluation kits for all of the components available. So what you've seen before, the BL3M, is available in 2 options. One is with a 2-wire interface and one with a 4-wire interface. And these 2 boards are suitable to directly connect to one of our BiSS sensors. If you want to implement an SPI sensor, then I recommend you the BL1D. It is also suitable to evaluate our BiSS Line master ICBL. So if you intend to connect the BL1D or the ICBL component directly to your microcontroller, then please use the BL1D. And on the right side, you can see our BL1U, which is our BiSS Line master adapter, suitable to connect to any BiSS Line slave, and then use our software GUI for a simple configuration and communication. Once again, thank you very much. And if you now have any questions, please do not hesitate to contact us.
iC-Haus. Integrated circuits.